you that don't know me, my name is Julian Fernandez. I'm the CEO and co-founder of FOSSA Systems, which is a company dedicated to the development of PocketQube. So most of you probably already know FOSSA from our last mission, FOSSASAT-1. But anyways, I'll still do the typical introduction for those of you that are new around here and that don't know this small community. I tend to say it's a lot. PocketQube community is tiny. We're probably 100 or 150 people worldwide. So in the end, most of us already know each other. So as I was saying, FOSSA Systems is dedicated to developing Pico satellites. We work with the PocketQube form factor. And we've recently launched a mission on an ALBA pod cluster in 2019, the FOSSASAT-1. Actually, this time last year, we were presenting our FOSSASAT-1 project, and now we have the results. We've launched it into space, and we're able to explain the results now in this presentation. So the goal of this presentation is going to, very briefly, since we have limited time, and excuse if I go over things a bit too quickly, go over the results and go over the timeline of events for the future of FOSSA Systems. So we'll be going over the FOSSASAT-1 mission and results, the Pico bus mission, which is due to launch in the next couple of months, with the FOSSASAT-2 and FOSSASAT-1B satellites, as well as our new Pocket Pod deployer, which is aimed at giving, well, low-cost access to LEO services, and our latest generation FOSSASAT-2E satellite. So a bit of introduction on FOSSA Systems. We were founded in 2018 as a non-profit student association, and we were founded based off a series of events online, a bit following the PocketQube community. We met on Reddit as a group of students and individuals, and we decided to launch a satellite into space. So I think FOSSASAT-1 is a great success story as to how just a bunch of students got together and managed to, well, launch a satellite into space with little to no funds available. And I'm just really realizing now, I think the presentation is not being seen in full screen. So I think we're gonna have to continue like this, but excuse the fact that the presentation is on full screen. So we've already launched a satellite into low Earth orbit, FOSSASAT-1, which was designed as an open source project and is able to be, well, seen online on GitHub. And actually, there's quite a lot of universities and individuals which are using it as inspiration for PocketQube launches. And we also designed the FOSSASAT-2 and 1B satellites, and now we're advancing as a company. So we recently got established as a corporate entity. So we're starting to deliver commercial services both in low Earth orbit launch brokerage. So that is with our Pocket Pod deployer for PocketQubes, and satellite bus and satellite platforms services. So that is putting a platform in space for a client to have their hosted payload on board the platform at a very low cost. So FOSSASAT-1, as I was saying, started development in 2018. It was a bit of our first steps in the PocketQube community. So we were still learning about how PocketQubes worked. We wanted to demonstrate an Internet of Things payload in space dedicated to LoRa telecommunications. And as you can see in the pictures, it's a 1P satellite with deployable solar panels. So it was actually, back in the day, the smallest PocketQube, well, I think the smallest satellite in the world to have deployable solar panels. A bit more on how that went in the next slide. But this satellite was meant to create an Internet of Things network in space. So back in 2019, we launched the FOSSASAT-1 into space. You can see here the picture of myself in the clean room during manufacturing, and then during integration. And thankfully, well, we were able to launch it successfully into space. And well, our first PocketQube project, we didn't really know what to expect. It's quite a task to launch a satellite into space without any previous experience. And as a student group, it was quite a daunting task to launch this into space on various levels, due to legislation, due to funds, due to technological development, etc. But in the end, we actually achieved it. In fact, most of you will probably know this from Twitter. We're quite active on Twitter with regards to our updates on our satellites, and there was quite a bit of attention on the FOSSASAT-1 satellite due to the fact there was so much international involvement. In fact, since the first day that we launched it on the Alba pod, well, it flew on an Electron rocket. An Electron rocket from Rocket Labs. We had a lot of individuals, especially amateurs, listening to the satellite to hear these first signals. And in fact, an hour or two after the separation from the deployer, we got our first RTTY signals. So for us, this was already a huge achievement. It was a first, to be honest. I don't think it was something that had been done before in this way. So we were very happy to have received the first RTTY signals from the satellite. However, not everything went exactly according to plan. What you can see here in these slides are two RTTY signals from a station in, I believe this is the Czech Republic, and China. We actually had some amateurs in China which were involved in receiving packets from the satellite. And unfortunately, due to an issue in one of our burn wire mechanisms, we were not able to deploy the solar panels and antenna completely. So we had a limited performance on the emissions coming off the FOSSASAT-1 satellite. Due to this, we actually had to hand decode some of the initials RTTY packets from the satellite. So this is one of the points which I wanted to give on this presentation. And it's just how important it is to have redundant transmission protocols. The IRU insists on this. In fact, they were quite skeptical on LoRa, and they wanted us to use a redundant ham amateur-oriented protocol. So that's why we integrated RTTY. And in the end, we actually received about half of our total packets on RTTY. And it allowed us to decode very, very low power packets at incredible ranges. So that's one interesting consideration which we learned of the FOSSASAT-1 mission. And we also managed to test LoRa successfully. We managed to decode packets from the satellite, and we managed to demonstrate that LoRa transmission and reception from space was actually possible. Also, with the involvement of the amateur community, some users were able to record SDR packets with an SDR packets off of the satellite and then decode them on Earth. So regarding the actual results which we got, besides the functionality and proving the bus, we were also able to get thermal data off of the satellite. And excuse 1 second, cat is on the keyboard. Back to what I was saying. Regarding the actual data, we got a lot of thermal information of the performance of the satellite. And we were working with a company called Julian Systems, which carried out the thermal analysis of the FOSSASAT-1 satellite. And in that regards, well, we have some articles published online, and we were able to see that the temperature ranges of a 1P satellite are actually quite limited. In fact, we're seeing a variation of our battery from around -5 to 15 degrees, and we were quite surprised by this, considering we had initially considered the need for resistive heating for our satellite. And then externally, we were hitting ranges from -25 to around 50 degrees. Regarding the EPS performance of our satellite, there's some results here regarding our battery performance and our temperatures. I won't go over exactly what we found, considering there's a report which will soon be published, which goes fully in detail over what we learned for the FOSSAT-1 mission. However, we did see that linking the thermal model to the EPS was very important, since low temperatures had quite a large influence on our satellite battery, and that testing and standardized procedures are imperative to having a successful mission. So FOSSAT-1 was a success. It worked for 3 months. You could consider it a partial success because we didn't achieve our full operating lifetime and we didn't deploy our antenna completely. However, we were still able to achieve probably 70 to 80% of the mission objectives which we had established. Regarding our next missions, one thing which we're working on since already the launch of the FOSSAT-1 mission was the Pico bus cluster, which we're launching on the Firefly Alpha rocket in the following months. So this is a collaborative project which we took on, and we actually got the prime contract for, even though it was a free launch opportunity on a maiden flight from Firefly on their Alpha rocket. So we're still pending to see how that goes. And Libra Space developed an 8P deployer for this project, while we flew the FOSSAT-1B and FOSSAT-2 satellites. AMSAT flew their Genesis N and Genesis L satellites, and Libra Space flew their cubic satellites. So it was a bit of a very big experimental launch, which we were carrying out to test lots of technologies, including, for example, a collaboration between AMSAT, Applied Ion Systems, and FOSSA Systems to test a pulsed plasma thruster in space. So the FOSSAT-2 and 1B are the next iteration satellites from the FOSSAT-1, which are obviously the FOSSAT-2 in a different form factor. It includes a new GNSS experiment by the European Space Agency, a camera, a full magnetorquer ADCS, and we have a LoRa repeater, as well as having moved over to the STM32 architecture. While the FOSSAT-1B has an updated burn wire system, updated internal electronics, and a LoRa repeater. So these are the satellites which we'll be launching in the next couple of months from Vandenberg. So after having launched the FOSSAT-1 and the FOSSAT-2 and 1B, which are pending to launch, we discovered that there was this lack of launch opportunities for PocketQubes in the market. Right now we have Gauss and Alba Orbital. However, considering the increased size of the PocketQube in the last couple of months, we considered that it was necessary to fill this gap to increase the launch opportunities of PocketQubes to low Earth orbit. So this is why we developed the PocketPod, which is an 8P deployer using a high reliability pin puller developed by Deployables Cubed, which will actually be giving a talk here in a couple of hours. And what we're trying to do with this is reduce costs to access space. So the launch cost for a 1P is 18,000 euros. We offer discounts for educational and non-profit missions, and we're also able to offer testing services for companies and educational institutes so that they can test their satellites at our facilities. We work closely with the National Aerospace Institute of Spain, so we have TVAC, SRS shock, and vibration table testing facilities, which we can offer together with the launch. So our first cluster will be launching in April of 2021. 9 satellites will be launched, and we have 5 customers on that mission. And there's an ICD available, which should be online soon, as well as you can contact me through email to discuss if you're interested on the payloads user guide regarding the levels or the ICD. We're using an PocketQube XL envelope, so it's fully backwards compatible with the Alba pod. And we're also able to mount the pod in a vertical position. So we're able to better optimize space on, for example, this is the Momentus Vigoride platform, which we'll be flying in April. and lower costs. So our planned launches are April 2021, Q3 2021, and Q1 2022. And we have a configurable orbit of between 450 and 550 kilometers. So our clients are also able to have some decision as to where they're being placed. So here are our constituents. We're flying the FOSSASAT-1, the Challenger by Minikubes, which is a 3P Earth observation payload. And we're flying the Canary Hatchling by Kerweather Technologies, which will be testing the actual platform, the satellite bus. And in the future, we'll be testing radars, as well as 3 FOSSASAT-2 platforms, of which 2 are carrying missions by Porkchop, which is an experimental pulsed vacuum arc thruster, and a Sea Shark satellite, which will be testing IoT services in space. So regarding the FOSSAT-2E, which will be launching in April on this initial mission, here are just some main characteristics of the satellite. However, I would like to say that there is an infographic on our Twitter and on the exhibitors page for FOSSA Systems, where you can see more information regarding the satellite. We also have an ICD available for payloads, where they can see our standardized space. But just going over the main specs, we're talking about 1P payload space. We have up to 9 watts of power, a downlink of up to 0.25 megabits per second. And most importantly, we have a cost of 100,000 euros, including launch into low Earth orbit. So quite competitive compared to the current solutions. And to our understanding, it is the most, the least expensive platform currently available in the world for satellite payloads. Excuse the speed at which I went over all of this information. There was a bit of limited time for all the topics which we had to cover, but I'm available online through Twitter or through my personal email. My colleague Vicente Gonzalez will be giving a talk in a couple of hours, I think just after the lunch break, and he'll be discussing the FOSSASAT-2E platform and our PocketQube launch services in more detail. So if you're interested, you can also attend that session.